everyone, and welcome to another video. Now, today we want to look at the derivative of the natural log of x from the first principle. So we want to look at the derivative of the natural log of x, ln of x. Now, the first thing that you are supposed to know is what do we mean by this natural log or the ln. So when you have, this one originates from the logarithms. For example, if you have the log of a number, for example x to base 10, that one I know you all know that. Simply, and also this one, and again, if you have the log, you can also have the log of 2 to base 10. You can also have a number, log of 3 to base 10. But log of, for example, 3 to base e, then that means this is the natural log of 3. If you have log of 7, for example, to base e, that is, you can say that is the natural log of 7. So, in other words, any log to base e is the ln of that number. So, let's look at the derivative of it. And here, we want to derive it from the definition of the derivative. Yes, so solution, before we dive in here, in case you are watching us for the very first time, please subscribe to this channel so that the next time we produce a wonderful video like the one that you just want to watch, YouTube will automatically notify you. So the function, let's look at the derivative of the function and from the definition. So let's say from the definition, of the derivatives. So from the definition of the derivatives, so we say as limit h is tending to be 0, then the function plus h, the function of x over h. That is the definition of that. So we just want to replace that with that. So as the limit h is tending to be 0, then we have the natural log of x plus h minus the natural log of x over h. So you can see there is something which is approaching here, and you know the law of logs when you have the negative there. So if you have the negative here, then what can you do to the log? Then you can divide the log. So can you apply that? But before we do that, I can see the h here, I can take it outside. So when I take it outside, then we have as the limit h is tending to be 0, then 1 over h multiply by the natural log of x plus n minus ln of x. This one, put it all over the bracket. Yes, it's very beautiful. So as the limit, so we can apply the law of logs here. So as the limit, again, h is tending to be 0, then we can apply here. So we have the natural log of x plus h over x. Sorry, this is 1 over h multiply that when you apply the law of logs. So again, we can apply the third law of logs, so by taking 1 over h the other side. So we have as the limit h is tending to be 0, then we have the natural log of x plus h over x. This one is raised to 1 over h. It's very beautiful. So I want you now to see that. We want to define what we mean by E, that we just look at while we were starting this video. So we know that the E is equal to, as n approaches infinity, then we have 1 plus 1 over n raised to n. So that is the E by the definition. So we want to put this one in terms of this. We want to put this one in terms of this. So the first thing, for me to achieve the one which we have here, then that means that I'm going to divide this one out. Yeah, I know you can see it. I'm going to divide both sides here, everything here by x. So I have, as the limit, h is tending to be 0. Then we have the ln of, divide that, we have 1 plus h over x over 1 over h. So we have achieved that. Already we have achieved that. But you can see that E, we have 1 over n, and that n is also the power. So you must have 1 over something raised to that something, you guys. But now, how can we achieve 1 over? 1 over. So that means if I want to put this one 1 over and get our original value, which is h over x, then that means here h over x, I'll put 1 over x over h. Because when you have 1 over x over h, that means that you have 1 divided by x over h. And this one you have 1 multiplied by h over x initially, which is what we have initially. So for me to achieve 1 over, then you take 1 over of the reciprocal for you to get your initial value. So that means we have, as the limit h is tending to be 0, then the ln of 1 plus, let's do that now here, then we have 1 over x over h raised to 1 over h. It's so beautiful, you guys. So we have achieved this 1 and 1 over. But now there's something which is remaining. I don't know, you can see it. Whatever is here, which is x over h, must be the power. So how can we do that, you guys? This is how you can approach it. So let's say that, let's put up here x over h. Is it? But now that one we have changed everything. For us to get 1 over h, which was initial, then I'm going to multiply this by 1 over x. So that when you have x over h multiplied by 1 over x, that one will going to cancel out. The x and x will leave the system, then you remain with your initial value, which is 1 over h. So as the limit h is tending to be 0, then the natural log, the ln of 1 plus 1 over x over h is equal to, now what I want to do here is that 1 over x doesn't contain any that variable which is h. So that means we don't have any, so we are going to apply the law of logs, take it the other side. So we have 1 over x multiplied by that. Then we are remaining with x over h up there. So let's now relate it now. Have we now achieved everything? Yeah, we have achieved, because now here we have 1 and 1. We have 1 over a number, like now here, x divided by h is equal to our n. But the same thing, x over h is our power. So that means that we have achieved what we want. So let's now wind up here. So as the limit h is tending to be 0, then we have 1 over x as the limit h, because this one is all over that. H also, limit h is approaching 0. Then we have the natural log of 1 plus 1 over x over h is equal to x over h. So you can see here that 1 over x doesn't have that h in it, so that means we're going to have 1 over x. You can see it has started coming. Beautiful. Math is very beautiful, you guys. So that is 1 over x. Then, as the limit, we know that as the limit to h approaching, then this one is equal to e. So we have the natural log, which is the ln of, because this one is equal to e. But remember, we said that now, for example, if you have the log, this means when you have the log of e, natural log of e, simply means it is a log of e to the same base. So what is a log of a number to the same number? Is 1. So that means 1 over x multiplied by 1. And we have the derivative of the ln of x is 1 over x. As beautiful as such. So you guys, 1 over x is the derivative of the ln of x. So if you've learned something, please give this video a thumbs up. And let's see you in the next video. Bye bye.